Hello, welcome back to Tutor Think. In this video, I'll be taking you through Introduction to General Differentiation. In this part, I'll be talking about basic functions, basic simple functions, and how to differentiate them. So if you haven't subscribed yet, please subscribe to this channel. Click on the notification button for more updates. So let's start what we have today. So the first basic function I'll talk about is I'll be using the variable y and x. So the first function I'll be talking about is if we have y equal to x raised to the power n. Now we have a variable y being equal to x raised to the power n, where n here is an exponent. Now n is an exponent, or the power, or what we call the degree. And anytime you come across a function of this form, how do you differentiate it? So it is very simple. All you need to do is that pick the exponent, use it to multiply the function, and reduce the power or the exponent by 1. So now I am about to differentiate y with respect to x. So if you differentiate y with respect to x, you write what we call dy dx. So I have dy dx equals nx n minus 1. So you use the exponent to multiply the function, you reduce the power by 1, so n minus 1. So that is all. All you need to do is now to simplify the result. Let me take an example. So if I have something like y equals x raised to the power 2, where 2 here is standing for my exponent, which is n. Then from this rule, we learn that dy dx will give us 2 times x, 2 minus 1. So now this result is going to give us 2x raised to the power 1, which I need not to write. So now this is our final result. Let's take the next example. Let's assume we have y equals x raised to the power negative 3. Now, applying the same rule, all we need to do is dy dx is giving us, use the exponent to multiply, minus 3 x raised to the power minus 3 minus 1. Reduce the power by 1. Now this result is going to give us minus 3 x raised to the power minus what? 4. And that is your final answer. Let me take the final example before I move on. If I have y being equal to x raised to the power half, I can use the same rule because half here becomes my exponent. So dy dx equals 1 out of 2 x raised to the power 1 out of 2 minus 1. And we are learning that use this to multiply, reduce the power by 1. That is what I have done. Now when you simplify this, we are having 1 out of 2 x raised to the power of negative 1 out of 2. You can punch this side on your calculator. When you subtract 1 from half, you'll be left with what? Negative 0.5, which is half. And this becomes your what? Final answer. Don't forget that I can also deduce this into square root form. I can simplify this again, but I'm not talking about that, so I won't continue. You can leave it here. Now let's take the example 2. If I have y equals ax raised to the power n, it's still the same thing, and I will use the same process. Now look very carefully. This a here is a constant. I'm just using it to represent a positive and a negative value. So it is a value that will always be the coefficient of what? The x. When you look at the example that we just did, all the coefficients of the x was 1. You see, there was 1 here, there was 1 here, there was 1 here. So there was no need for me to introduce that. Now, in the same way, just use n to multiply and reduce the power by 1. This a will multiply n and multiply the function, and you generate your final answer. So here we have our dy dx is going to give us a times our n x raised to the power n minus 1. So this is still giving us a n x raised to the power n minus 1. And that will be your final result. I repeat, A that you see here is the coefficient of what? X. It doesn't matter. It can be a value which is positive or what? Negative. So just use n, the value you have at the exponent, to multiply it and reduce the power of n by 1. So now I'll take an example under this one. Let's assume that I have y equals 2x raised to the power 4. So now a here, which is the one we have here, is representing our 2, like I explained earlier. So dy dx is gonna give us 4 times 2, giving us what? 8. X raised to the power 4 minus 1. And this is giving us 8x raised to the power what? 3. Another example, y equals minus 3x raised to the power 2. Then when we differentiate this, we are getting dy dx equals minus 6x raised to the power 2 minus 1 will give us what? We are getting what? Minus 6x raised to the power what? 1. And this is our final result. So dy dx equals negative what? 6x. Remember that no matter the value they put here, it's still the same thing. The value here can be a decimal number. All you need to do is use the exponent to multiply. As simple as that. So let's go to rule number 3. Now, if I have y equals to a, where a is a constant, at this point a is representing a constant, a positive or a negative value, then the derivative of this one will give us 0. So we always say that the derivative or the differentiation of a constant is always what? 0. So this one, dy dx equals what? 0. Why am I saying that? Now watch very carefully. We can see that we do not have the variable x that I was using here. I don't have x raised to the power n. The x raised to the power n here is hidden and it is the same as 1. Why am I saying that? Now whatever we see here, y equals to a is the same as y equals to ax raised to the power 0. Note that anything to power 0 here is 1. So the variable x here is representing 1. So 1 times a will still give us what? A. So now when we differentiate this, we are going to get dy dx equals 0 times a times x raised to the power 0 minus 1. Remember that we are still using this same rule. And so 0 times everything here makes the whole function equal to what? 0. So that is why we say that the differential of a constant is always what? 0. So for example, if I have y equals 2, where 2 is a constant, then dy dx equal to 0. There is no need for you to pass through this step. All you can do is to say 0. Again, if I have y equals minus 4, then dy dx equals 0. If I have y equals 1000, still we have dy dx equals what? 0. We got the concept. So let's move on to rule number 4. In the fourth rule, I have picked the exponential function as my fourth rule. Now, if you come across an exponential function, which is this one, there is a special way you differentiate it, no matter where you see it. So far as you are differentiating the function, you need to know how to differentiate an exponential function. Now, the derivative of an exponential function is very simple. Remember that whatever that I have here, I have e to power ax. I am always using a to represent values. So this a can stand for a positive number or a negative what? Number. So when you see something like this, how do you differentiate? Derivative of this, which is dy dx equals, use the coefficients of the x you have here. Remember that it is not always that you come across a function or an exponential function having its variable x. this variable x can change. It can be u. It depends on the function that you are working on. So do not be confused when you come across a different variable, let's say u. Don't say you haven't seen it before. So all you need to do is that the coefficients of whatever variable you have here, use it to multiply the function and raise it to the same power. That is all. So this will give you a e raised to the power of ax, and this is how you differentiate an exponential function. Let me take an example. If we have y equals, let's say, e to power 2x, then this 2 is representing my a. Use the 2 to multiply the function and raise it to the same power. That is all. So we have dy dx equals 2e raised to the power the same 2x. You get the concept. So that is it. Let's take the next example. Y equals e raised to power minus 3x. Then dy dx is gonna give me what? Minus 3 e to power minus what? 3x. And that is it. Very simple. Whether this side is a fraction or not, repeat the same step. So if I have 1 over 2 here, just use 1 over 2 to multiply, raise to the same power 1 over 2 or 0.5. So this is my rule number 5. For this one, we have y equals sine x. It is very simple. What will be the derivative of sine x? Remember that these variables that I have here, which is y and x, it depends on the function you come across. It can change it. I am just differentiating y with respect to x. It can be p with respect to a. It can be q with respect to any other variable. Don't be confused. Just remember the rules. How do you differentiate a sine function, a cos function, a tan function, and the rest? So now this one, we have dy with respect to this x, dx equals cos x. As simple as that. So when you differentiate sine, you get what? Cos x. Okay, so let me take an example. Let's assume that we have a function y equals 2x squared plus sine x. And you are asked to differentiate this. So all you need to do is that dy dx equals, don't forget we have already learned a rule for this one. So this will give us 2, giving us 2 times 2, 4. Reduce the power by 1, you have what? X. Plus differentiate sine. We learned that the differential of sine is what? Cos. So we have plus cos x. And that is our final answer. Now when we have y is equal to cos x, the differential of a cos function, what will you get? So we have dy dx equals minus sine x. Remember, the differential of cos will give you minus sine. The differential of sine, which we already did, will give you what? Cos x. Let me take an example. So now we have dy dx being equal to, now look at this. This is the first rule we learned. Just let's solve that side. 2 times 4, which is minus 2 times 4, is giving us minus 8. X raised to the power minus 2 minus 1, giving us minus 3. Then minus, now remember this negative will affect the results of your what? Cos function. So all you need to do is to put it in bracket. Now when you differentiate cos, what do you get? You get minus sine, the same variable. So minus sine x. You see? So this can now cancel this one, giving me dy dx equals minus 8x minus 3 plus sine x. Now this thing changed to positive because of this negative sign. So if this side was supposed to be positive or plus, then this side will remain what? Negative. So before I will talk about the trig functions again, let's talk about the simple one, the ln function. So we have the natural log ln x. Now this one can also be in logarithms. I will not talk about that right now. So let's box on. Now when you have y equals ln x or any other variable equals to ln anything, then the derivative function, which is dy dx, will be equal to 1 over what? X. So no matter the variable you have here, when you differentiate it, it will be 1 over what? That variable. The integral of this will generate what? What you have here. So when you integrate 1 over x, it will give you ln x. When you differentiate ln x, it will bring you back to what? 1 over what? X. Let's take an example. Let's assume that we have y equals to ln x plus 4. And we are told to differentiate this. Then dy dx is going to give us 1 over x, which is ln function, plus 0. Remember that the derivative of a constant is what? 0. So this will be our result. Now, listen to me very, very carefully. I have taken my time to explain this, but there is something I need to tell you. I said y equals ln x. When you differentiate it, you will get 1 over x. So the differential of ln x or ln u or whatever variable will give you 1 over that variable. Okay. Now listen carefully. As soon as the power here is more than 1, the result will never be 1 over x. Is that clear? Let's assume that the power here is what? 2 ln x squared. The result will never be 1 over x squared. Why am I saying that? For this one, there is a special way of answering it. It's either you apply the shortcut method or you apply what we call the chain rule. So now let me take an example for you to understand. If I have y equals ln x squared, the result for dy dx will never be 1 over x squared. The first thing you need to do is to take only x squared and differentiate it. So dy dx is going to give me what? 2x. Differential of this one. You are not done. Divide this result by the same x squared. And this is your differential function. You see? So when the power of x or the variable is more than 1, your result will change and it will be something like this. Now note carefully. I applied a shortcut method here. What I said was that consider the variable x squared, differentiate it, write it down, divide the result by the same x squared. But because it is a shortcut method, if you have a question like this in exams and you apply this, you will get it wrong. You will not get any marks for the steps. And so for a question of this form, you need to apply chain rule. I will not be talking about chain rule here in this one. Locate my video under chain rule for natural log functions and you will see it there. I've explained into details how to differentiate ln functions using the chain rule. Now we are coming back to trig functions. If I have y equals sine ax, where a is any number, any value, then what will be the differential function? This is also a special type of differential equation, and you need to apply what we call chain rule again. But usually there are always shortcut method. All you need to do is differentiate this side, bring out your result, and differentiate the sign. So for this one, dy dx will be equal to, the first thing is differentiate ax. Remember, a is a number. So now the exponent here, which is 1, will multiply a. Reduce the exponent by 1, which will give you x raised to the power 0. So the result for ax, when you differentiate only ax, is a. You are getting what? A. So write down your what? A. Now use your a to multiply the differential of sine. We also learned that when you differentiate sine, the result is cos. So I'll have my what? Cos. But cos what? Cos the same what? Ax. And this is my final result. So let me take the example for this one. Let's assume that we have y equals sine 3x. Then I said that differentiate 3x. When you differentiate 3x, the result is 3. Bring it out. So we have 3. Now wait. Differentiate sine. The result is cos. So we have cos the same 3x, and this is your answer. So now let me take the next example. Differentiate 2x squared that you have here. The result is 4x. So now bring your 4x outside. I have my 4x. Hold on, multiply it by the differential of sine. Differential of sine is cos. So 4x cos the same 2x squared. And this will be your final result. Now, if we have y is equal to cos ax, the same as the first example we did, we learned that when you differentiate cos, the result is minus sine. So first, we have our dy dx is giving us what? Differentiate ax, the result is a. Wait, use it to multiply the differential of cos. Differentiate cos, the result is what? Minus sine. We learnt that. The same what? Ax. So this one, the result is giving you minus a sine ax. Now let us take an example. Differentiate 4x. The result is what? 4. So dy dx is giving us 4. Hold on. Differentiate what? Cos. The result is minus sine. So I have my minus sine, the same what? 4x. So the simplification of this is giving me minus 4 sine 4x, which is the same as your dy dx. And this is your final answer. So this is how you differentiate these basic functions using the differential rules. I hope this video has been very useful to you. In the next part of this video, I'll be talking about chain rule, quotient rule, and product rule, and other ways of differentiating other functions that are a little bit complex. So this is the end of this one. My name is Daniel. Subscribe to this channel if you haven't, and I will see you in the next one.